Okay, it's time to practice for MAC 1105 exam material part 4. Okay, the semester is approaching and here we have some questions. Alright, so we've been graphing logarithmic functions, exponential functions, and so we're going to have to graph one of those, right? So let's say, for example, we're told to graph this function, which you should recognize that it is an exponential function. Okay, we've talked about it before. We talked about, let's say that the function is just 2 to the x, right? This means that shifts were done to it, right? What was done to it? It was shifted 2 units to the right, the entire function, all the points, and then also all the points are shifted 3 units up, right? So if it's just 2 to the x, we've graphed that before. Remember, you always want to make a chart, plug in some negative values. 0 is always a good one to plug in, considering it's the y-intercept, right? And then also some positive numbers. So we'll graph that. And so we're basically told, can you graph this function? And you could do it either using shifts or by making a chart. So we'll do both. But just want to say that for 2 to the x, we've talked about it, there's a horizontal asymptote at y equals 0, right? So if there's a horizontal asymptote at y equals 0, then when you shift the function, then of course the the horizontal asymptote will also shift, right? So if this is shifted 3 units up, let's say the function was like this, because it's an exponential function, 2 to the x, right? That's going to be growing exponentially fast. And so if you shift this 3 units up, 1, 2, 3, now of course the horizontal asymptote will now be at y equals 3. Now you can't just put 3 because 3 makes no sense, right? This 3 an ordered pair is, what is 3? So you have to say y equals 3 if it is a horizontal asymptote and x equals 3 if it is a vertical asymptote, okay? So let's start plugging in. So let me erase. Okay, but that right there, we've already answered part of it because it said find the horizontal asymptote. So we already know that the horizontal asymptote is y equals 3. Right, it's shifted 3 units up. Okay, so now let's do this by plugging in. So let's plug in some numbers, and that's maybe plug in 0, -1, -2, 1, and 2 to see what happens. All right, so just plug in, and that's why order of operations and exponents is very important. So if I were to plug in 0, I'll do it here. F of 0 is 2 to the 0 minus 2 plus 3. Okay, what's 0 minus 2? -2. So this is 2 to the -2 plus 3. And we know 2 to the -2 is 1 over 2 squared, right? Which is 1/4. So then you do 1/4 plus 3, which is 3.25, right? Okay, now let's plug in -1. Let's do it up here. Plug in -1, that means it's going to be 2 to the -1 minus 2 plus 3. What's -1 minus 2? -3. So this is 2 to the -3 plus 3. Okay, well, 2 to the -3 is 1 over 2 to the 3rd power. Remember that you can make exponents, negative exponents positive by bringing it to the denominator. Right, so what's 2 to the 3rd power? Or in other words, what is 2 times 2 times 2? That's right, it's 8. So that would be 1/8 plus 3. So that's going to be 3.125. All right. Now let's plug in the other values. F of -2. Okay, so that's going to be 2 to the -4th plus 3. Or in other words, 1 over 2 to the 4th. Okay, what's 2 to the 4th? That would be 2 times 2 times 2 times 2, which is 16. So that's 1 over 16 plus 3. Okay, so that would be 3 and 1/16. I don't have the calculator right now, but you could just plug it in the calculator. Okay, now let's plug in 1. Maybe over here. F of 1 is just simply 2, 1 minus 2 plus 3. So that's going to be 1 minus 2 is -1. So that's 2 to the -1 plus 3. Or in other words, 1/2 plus 3. So that's going to be 3.5. And last but not least, plug in 2. It's going to be, it's going to be 2 to the 2 minus 2 plus 3. That's just 2 to the 0 power. What is anything to the 0 power? That's right, it's 1. So 1 plus 3 is 4. Okay. Let's plug those in. And honestly, I think that we should have plugged different points. I think that if the horizontal asymptote is now 3, which it is, oops, let me get a different color. This is why it's always good to think about what you're doing. Nope. Okay, here we go. So if y equals 3, 1, 2, 3, that's our horizontal asymptote. Then that means that, of course, the exponential function is not going to touch it, so it's going to be over here. So perhaps we should have, no, I think the points that we got are fine. We picked -2, -1, 0, 1, 2, so it's going to give us numbers in this region. So we should be okay. So as long as you pick some negative numbers, 0 and some positive, you're going to be able to get both sides of the function wherever it's at. Okay. So let's graph. Okay, so -2 and 3. Okay, well, let's get that worked out. -1, 3.125. So just a little bit above 3. 0, 3.25 is going to be 3 1/4 past 3. Probably lower. 1, 3.5. And then 2, 4. Maybe I should have gotten one more point. Maybe I should have gotten 3. Let's plug in 3 really quickly. Up to the third power is 2 to the 3 minus 2 plus 3. 3 minus 2 is 1, so that's just 2 to the first power plus 3, which is 5. So it's going to be 2, 5. So here you can see, 3, 5. So here you can see the exponential part of it. And of course, this 3 and 1 over 16, if I had the calculator, I would just plug it in, but I'm going to know that this is a very small number, so I'm going to get very close to 3. It's 3 point something, probably 3.0 something. So -2, don't touch 3, but like right above it. Right, so let's put the vertical asymptote again, make sure we don't touch it. And now let's connect our points. Let's erase this. Let's connect our points. Yay! Right, I think this is more useful than graphing with shifts. Yes, it's good to know that it shifted 2 units to the right and 3 units up, but that means that you would have to first shift 2 to the x. So if you wanted to do it by shifts, you would first graph 2 to the x, plug in negative numbers, 0, some positive, and then you would have to get the points and drag them all 2 units to the right and 3 units up. And so along the way, you could kind of mess up or put them in the wrong spot. So to be precise, I think it's better to just use the function that you're given. But if you had to answer questions, you could say how it shifted, right? Okay, so that's that. So that was number 1. Okay, number 2, and the rest is pretty fun. Number 2, simple, write this logarithmic form in exponential form, okay? So in other words, we're going to be working with log. Yeah, we're going to be working with logarithmic functions. So it's log 7, 5x plus 8 equals 9. How do we write this in exponential form? Well, what is the base? The base is always a small number, 7. What's the power? The power is always on the right-hand side of the equal sign. So that's 9 equals this solution, whatever this number is. This is the number, 5x plus 8. Okay, and that's it. Does it say to solve? No, so that's it. If you had to solve, then you would figure out what is 7 to the 9th power, solve for x, right? If you had to, which in this case we don't. Easy. Okay, part B is the other way around. So now part B, it gives it to you in in exponential form. Let me put it higher. Exponential form, and it tells you to put it into a logarithmic form. Okay, which means I need to first put log, right? So start off logarithmic form with log if you get stuck. Okay, so it's log. Let me make sure that this is not creating extra light. Okay, so the base is 6, right? So 6 right here. What is the power? Don't get confused. The power is what 6 is raised to. So that's 3x minus 5. Wait, give me a second. Yeah, so that's the power, right? So the power goes on the right-hand side. And then the solution is a number. All right, so we're working backwards, right? We're used to going from log to exponential because it's useful. So if you want to, check yourself. Is this equivalent to that? Well, here's the base 6. The power is 3x minus 5. The solution is 1. Yes, we did it correct. Okay, so that's part 2, A and B. Okay, now it's getting super fun. And you can go back and rewatch the video or pause it if I erased it too quickly for you. Okay, 3, we have to write this as a single log. Okay, so we have sum and differences of logs, and we're going to try to use the properties that we've learned to get the job done. Minus 1/5 log b plus 6 log x plus 4. Okay, so first we want to apply everything that we've learned, right? So first of all, I already see something that I can do, right? We have 3 properties. We have property 5, which is the one that when you add, the summation becomes a product. Property 6 is that the difference of logs becomes the quotient or division of them. And then property 7 is that you can put the power in the front, right? The power in the back, you can now put it in the front and just get the log of the number. Okay, so I see numbers, right? I see 4, I see -1/2, well, I see 1/5, and I see 6. So I can tell that these were powers in the back. So let's start off there. So let's put them back where they go. So 12x minus 1 to the 4th power minus log b to the 1/5 power. Okay, and then plus log of x plus 4 to the 6th power. Kind of crazy. It looks crazy, but it's not. Okay, so that's the first thing. Okay, now we have to think about it. Remember that what are we doing? We're trying to, well, we're not trying to solve for x. We're just trying to write all this as log of something, right? So here we have a difference, right? Okay, so let's see. All right, I'm gonna start with these two because notice how this is log b. The base is b. Wait, give me a second. Never mind. These are all the same log. Okay, this is just the number, right? The number is expressed as a variable, so b. Okay, so never mind. Okay, so let's start off with maybe the differences. Okay, so for the differences, you know that that's a quotient. So let's see. So it's going to be the log of 12x minus 1, okay, to the 4th power, divided by b to the 1/5. Okay, check it. Property 6 would say that you would be able to subtract log of the numerator minus log of the denominator. Okay, so this is good, but we missed something because remember that we still have this plus log x plus 4 to the 6th power. So my question is, disregard this subtraction one, right? If you just looked at the first term and the third term, you would see that it's a sum of 2 logs, which you could use property 5 and make it back into a product. So that means that they were a product. So the question is, should it be in the numerator or in the denominator? Now we know it should be in the numerator because remember that the numerator stays positive. Whatever sign it is, it stays at, right? If it's in the denominator, that means there's a negative in front because we had to subtract whatever log of the denominator was, right? So in this case, if this was negative, that means that this would have been in the denominator, right? A product, but in the denominator. Okay, so let's just do it and let's check it. So that means I need to add dot for product and add x plus 4 to the 6th power, right? Let's make sure that this makes sense. Let's check it. So this would be log of 12x minus 4 times x plus 4 to the 6th power, right? Then you would use property 5 and you would break it up and it would be log 12x minus 1 to the 4th plus log x to the 4th, x plus 4 to the 6th, and then minus that log b to the 1/5. Okay, so we did it correctly. All right, remember that the sign matters and you want to be super careful because if there's 2 terms here, then both of them will have a subtraction sign in front. Okay, so let's check out the next one. Maybe the next one will be better practice in that sense. Just be careful. Okay, number 4. Okay, Let me just make sure it's good, yeah. Okay, number 4, write the following as sums and differences of logs. Okay, so now we're doing the opposite direction. We have something in the numerator. We have ln, which is natural log base e, right, log e. And now we have to use properties. Okay, so let's start off with ln bracket, because there's two things, of the square root of x, and this is why I gave exit tickets. Every exit ticket that I've given is something that comes out in an exam, pretty much. So first day of class, I gave an exit ticket, one, maybe the second week. I gave an exit ticket that had to do with, no, it was the first day of class, linear equations. And that exact problem, well, different numbers, came out on the exam, because if it's an exit ticket, that means I think it's important, right? Whether it's systems of equations, solving a linear equation, something similar to this, write it as sums and differences. So that's very important to not only do, but to make sure that you check yourself. It's a good feedback moment. Okay, I get this, or I don't, but let's do the homework. Let me practice. Let me make sure that I get it so that I can show my understanding and excel in what I'm doing. Okay, so that's ln of the top minus ln of the denominator. Cool. All right, now this is a product, so I'm going to use property 5 and make it into a sum. So it's going to be the ln of the square root of x plus ln of x plus 18, okay, minus that last term. Okay, not done yet. Why? Because I need to use property 7. Property 7 says there's a power, you can put the power in the front, right? Remember that the square root has a power of 1/2. So I'm going to rewrite the square root of x as x to the 1/2, and now I can use property 7. Property 7 says, hey, put that power in the front. So now it's 1/2 ln of x. These are equivalent, but this is much better for us to use to solve it out, and also to make it just a sum. No powers, just a sum and difference of log. Okay, this is going to be plus ln of x plus 18, and this one has a power, so let's put that power in the front. So it's going to be minus 8 ln of z. Okay, so that's it. I'll pause for a second. Okay, so I do want to point out, let's say that instead of the product being in the numerator, let's make the product in the denominator. So let's just make the top x plus 18 and the bottom the square root of x. Okay, all right, no problem. I'm still going to use property 6, which is the one for division, right? So it's going to be ln of the numerator minus ln of the denominator. Awesome. So now what? Okay. Well, now I see that there's a product, right? So I can use property 5. But this is what I was trying to tell you guys with the exit ticket, which I think some of you got, some of you not so much. But this negative applies to both of these, right? So I would put the bracket after the negative. Instead of putting it here, I'm going to put it after the negative to make sure that I distribute that negative to the product that I'm about to create, right? So this is going to be the product of ln square root of x plus ln z to the 8. But notice how the negative is in front of both, so they has to be distributed, right? So this is going to be ln, let me pick maybe blue this time, or green, no. It's going to be ln of x plus 18 minus ln square root of x minus, you see it's distributed, ln z to the 8th. And then the last but not least, power product rule. What am I saying, power product rule? Property 7, which is put the exponent, don't forget, square root has the power of 1/2. Okay, if it was a cube root, it would be the power of 1/3, and so on and so forth. We've talked about that, right? That's 1/10. 1/10. Okay, so then just last step would be to put the number in the front. Okay, but this proves to you why it should be both negative if the product is in the denominator. Hopefully that looks good. Okay, number 5. Almost done. Okay. All right, number 5 says Solve the equation by making the bases the same. So we have 5 to the x power equals 25x minus 2. So we've done a similar one in class, different numbers, but same concept. So we know that if x to the m equals x to the n, meaning same base, two powers, then that means that the powers are equal, right? So if I can get these both to be the same number, the same base, then I can make this happen, right? So 5 and 25, that's awesome because that's the exponents of 5, right? 5 times 5 raised to the first power is 5. 5 raised to the second power is 25, right? So I can leave 5 as 5, and I'm going to rewrite 25 as 5 squared, right? It's the same, 5 times 5. Okay, but put it in parentheses because it's raised to a power, and now I'm going to use the power product rule. Okay, so now the bases are the same. I can apply this that says that the powers are equal. So that means that the power x equals this power, which is 2 times x minus 2. Remember that it's a number times 2 terms, so you have to distribute. So it's going to be 2 times x and then 2 times negative 4, which is 2 times negative 2, which is negative 4. And then from there, it's just a basic problem, and then look at that, it's actually the same answer that we got in class, but it was different. It was 4 and 16, right? So it was 4 and then 16 is 4 to the second power, right? But same concept. So the answer is 4. Plug in if you want to, double check that 5 to the fourth is equal to 25 to the second power. Of course it is. Okay, now we talked about what do you do, that was number 5. If you cannot make the bases the same, which is real life, right? In real life, things don't always work the way we would like them to. So number 6, let's say we have 4 to the 3x minus 2 equals 12. Okay, so 4 and 12 are in the same timetables, but in terms of exponents, 4 to the first power is 4, 4 to the second power is 16, so there's no way we can get to 12, right? So this is not going to work. So instead we're going to get the log. So you're going to log both sides to be consistent. So it's going to be log of the left equals log of the right. Okay, now use any properties that you can to try to get to x. So at this point you need to think about it. So I'm going to use property 7 because I see a power, so I'm going to put that power in the front. Okay, then I see that I can distribute the 3x minus 2. So that's going to be 3x times log of 4 minus 2 log of 4 equals log of 12. Okay, any other properties I can use? Well, we have numbers in front, which means that these were powers in the back. So this 3, I'm actually going to put him in the back. It's going to be 4 to the third power. And this 2, I'm going to put him in the back. So it's going to be 4 squared. So what else can we do? I see subtraction. Which property is that? Property 6. That means that it was division. So this is going to be, actually before I even do that, I guess we can go ahead and raise these powers. So 4 to the third power is 64, and 4 squared, or 4 times 4 is 16, right? Sure you study. Okay, now I'm trying to solve for x, right? So in this case, actually only have one x. So this guy that doesn't have an x, I'm going to cancel him out by doing opposite operations. Let me maybe put it over here. Okay, so I'm super close to x. Excuse me. I'm super close to x, right? X is just x times log 64 equals log of this. Well, what's the opposite of multiplying x by log of 64? Dividing by log of 64, right? So I'm going to go ahead and I'm going to have to do it on this side. Okay, so this is going to be x log 64 equals log of 12 plus log of 16. Remember that the base is in there, which is implied that it is common log base 10. So that means, which we do have the calculator to do that. So this is just going to be property 5. Property 5 says, hey, this is a summation of logs. You can put it back as a product. So this is actually the same as log of 12 times 16. Okay, so let's do the math. I do recommend being prepared and having the calculator for the day of. So 6 times 2 is 12. 0, 2, 1. 182. Okay, so last but not least, last step would be divide by log of 64, because the opposite of multiplying is dividing. Okay, so again, I don't have the calculator on me right now because I usually use my phone now. But if I had to, I would buy one. I have a graphene, but anyway. So I would just plug that in. So on your calculator, you would do log 192 divided by log 64, round it to the hundreds place, and get your answer. Okay? Alright, almost done. Number 8. Number 8 is one of my all-time favorites. So my husband always says that if Steve Urkel from Family Matters had a sister, it would be me. And that's probably true. But it's okay. That's not really... This thing always... It's not 100%. It's pretty creative though. There you go. Alright, so number 8 is my favorite. So it says log base 2, another awesome log base, plus log 2 x minus 6 equals 4. Okay, so what do we do here? Again, what are the instructions? Solve. So solve for x. So again, use your properties. Okay, so first of all, thankfully, these are the same log, which means I can use 5, 6, or 7. So property 5 says that addition is the product, right? So that means that I can actually write this as just one log of base 2 of x times x minus 6. Again, a summation of 2 logs is the same as the product of them. So that means I'm going to get to multiply x and x minus 6, and this is going to equal 4. All right, so distribute that x. So that's x squared minus 6x. Okay, now to solve, this isn't really useful. I'm going to have to write this in exponential form, which is why that's even a question and something that we do constantly. Right, so what does this say? What's the base? 2. What's the power? On the right hand side of the equal sign. And it equals this number. What do you know? It's your favorite, a quadratic function. What's 2 to the 4th power? That's 2 times 2 times 2 times 2. That's 4 times 4, which is 16. Now, it may seem like I'm going fast, but we do need certain skills before we even come into this class. And so that's order of operations, fraction work, factoring, I would even say, is a prereq that you should have in order to solve these problems. Okay, so it might seem fast, but maybe that means that you just have to review previous knowledge that, or previous topics. Okay, so let's go ahead and see if we can solve. Now, I have seen students try to solve for x like this by factoring out an x and solving. You're not allowed to do that. You need to have this equal to 0 in order to solve for x, which means we either have to factor or do quadratic. That's what we do for x-intercepts, right? So subtract 16 to cancel it out, subtract 16. So this is going to be 0 equals x squared minus 6x minus 16, right? So now we need to factor. So I'm going to go ahead and factor over here. Okay, x squared would be x and x. 16, I have options. It could be 1 and 16, 2 and 8, 4 and 4. But because it's negative, remember that the sign matters. Because it's negative, that means that one of them has to be positive and one of them has to be negative. Okay, if the 16 was positive, that means they would both be positive or both be negative. But remember, our whole goal is we're trying to get to negative 6x, the middle or inside term. So which of these is going to give me negative 6? 2 minus 8, right? So it's going to be plus 2 minus 8. Okay, if that didn't give me what I wanted, then I would just swap the signs, and that would hopefully give me the right inside term, right? So that means we're super close. We have 2 possible answers. We have x plus 2 equals 0, which means x equals negative 2, or x minus 8 equals 0, which means x equals 8. Okay, but remember, that we don't, with log base 2, we've graphed it before. The domain is 0 to infinity. Was it something? I believe it was something like this. Yeah, if I'm not mistaken. So the domain is 0 to infinity, so we're never going to have negative numbers for x. In fact, you would get an error if you try to do that in the calculator. So scratch that out and just give me x equals 8 as the answer. If you want to check, plug 8 in there, plug 8 in there, double check that when you get the log of those numbers, you get 4. Okay, so that's that. And then the last 2 are just some formulas that we're going to use. I wanted my brother-in-law to come out, but he ended up being busy, so he's not here right now. But he was going to talk about why do we use exponential functions for certain things. He's into the stock market, and we talked in terms of hedging funds and all that good stuff. A lot of times we use the exponential function to find the discounted price for the stock. So anyway, we're just going to use the formulas. So here we go. All right, so let's say that somebody wants to invest $10,000 at a rate of 7% compounded monthly. How much would the investment be worth at the end of 25 years? Okay, so first we need to have the right formula. So I asked you guys to memorize some formulas. So the compounded monthly one, one second. I just want to double check, but of course you guys were told to memorize. Okay, so I'll just go by my memory. But okay, so the yearly one, this is compounded monthly. Okay, so there's one about compounds continuously. So compound continuously is A equals P to the E RT. That's the one I was talking about. Then there's one that is compound interest, but yearly, versus doing compound interest monthly, right? That's the yearly one, and then the monthly one. Okay, hopefully I'm right on that. No, just give me a second to double check. Always good to double check. Okay, I was super close and not without this end. And then the other one, yeah, okay. So depending on what type of question you get, right? So this question says, okay, so that means that the principal, which is the amount that you start off with in either investing or having, you're asking for a loan of this amount or you're putting in this much money. So the P for principal would be $10,000. The rate is 7%. As a decimal, always write as a decimal would be 0.07. And then you would be doing this for how much time? Remember, it has to be in years, 25 years. Okay, so for the first question, which is number 9 on the practice test, it says compounded monthly, which would be this one. So just plug in. So that would be 10,000 times 1 plus 0.07 divided by 12, right? Because it says compounded monthly. How many months are there in a year? 12, right? So n is 12. And then this is all raised to the 12 times 25. Again, don't have the calculator on me, but just plug in and you should get the right answer. How do you do this? It'd be 0.07 divided by 12 plus 1, raise that to this power, and then multiply by 10,000. So I'll actually do it now because I have my computer, but let's first figure out the power. So that's going to be 25 times 12. Okay, so that's 300. So let me do it now so you guys can verify with your calculator. Remember that every one is different, so you might have to use the arrow for the power on the power button to raise it to the power, right? So it could be an arrow on your calculator, or it could be x to the y or y to the x, right? Just a number raised to another number. So just find it on your calculator, but let me do this. So 0.07 divided by 12. Okay, then add 1. Okay, then raise that. Where is it? Raise it. There it is, x to the y. Raise it to the 300th power, which is 12 times 25. And then, oops, I lost it. A second. I'll do it again. So 0.07 divided by 12. Add 1. Okay. Let me copy that. I'm gonna raise it. There it is. To the 300 power. Awesome. And then multiply that by 10,000. We get 57,254.18 when you round to the hundreds place, right? That's how much money he'll have after 25 years with this amount that he invested at this rate, compounded monthly for 12 months. Every year, right? Okay, so that's great. And then number 10 is just a simple one, or is the other one, which I think I had told you guys to memorize this one. I just know all 3 of these, right? Okay, so compound interest yearly, that's important. Why? Because let's say you want to work backwards, and I'm going to do a question. So let's say you work backwards and you want $100,000 with a certain principal at a certain rate, how many years? So that's that shows the power of log, because you could use the log function to find t. Okay, but the last one, which is number 10, is again the principal is still 10,000. You want to invest 10,000, but at a rate of 8.5%. Remember that 8.5% means you still have to turn it into a decimal. How do you turn percents into decimals? Divide by 100, right? So you can't put 8.5 because it's 8.5%. So 8.5%. If you divide by 100, right, grab the decimal, move it 2 times to the left, right? That means divide by 100, divide by 10, do it again, divide by 100. It's actually 0.085, 0.085 for the rate. Okay, and then for 35 years, but this person wants to compound continuously, and that is this amazing formula. So here you're going to plug it in, okay? And I had an awesome student ask me, what does A mean? So give me a second. I just want to read it for you because it's more precise. All right, so A represents the final amount accumulated. In other words, the total sum of money you will have after a certain period of time, right? So the total money this person would have after a certain period of time, which is 35 years, at this rate, with this money, initial money invested, would give us a certain amount. So you guys, in the calculator again, have the function E. So again, PEMDAS. Exponents before multiplication. So let's figure out what 0.085 times 35 is. Okay, so that's 2.975. So we're going to raise e to the 2.975. Again, you might just be able to, but depending on the calculator, you could just plug in e to whatever number, or you might have to do e to the power of, which would be the arrow or x to the y function in your calculator. Okay, so e to the 2.975 gives me some number, 19.59. Multiply that by 10,000. And you get this number. You get, 195,896.23. Remember, this is for 35 years. The total amount of money, a total accumulated after 35 years, it would be 159. Let me put the money sign. $195,896.23. Okay, now I'm feeling skeptical, so let me just do this again. I always like to check my numbers twice when doing formulas. It never hurts. Yep, that's the amount. Okay, so the last one I'm gonna do, that is important because it may or may not. It's just good to see the usefulness of log. Is one that I didn't exactly have time for with all the classes. I did it for one of the classes, but the other two preferred me to do it on the YouTube video. So let's say that this person wants to have compound interest done yearly, and the person wants $10,000 to invest. That would be P, right? Initial amount. The rate, let's say, is 9%. Okay, so that's 0.09 as a decimal. And let's say it's for, we don't know how many years. Okay, but we do know that this person, actually let me make it 1,000. Let's say that this person wants $100,000 accumulated after X amount of years. How many years would it take him to do that, right? So this is a working backwards type of question. So $100,000 is now A, the amount accumulated, or the total amount. Okay, P is the amount he starts off with, which is 1,000. And then this is 1 plus R, which is 0.09, the rate, to the T, right? So the question is, can you solve for T? And the answer is yes. So first of all, is there anything that we can do? Well, we can divide everything by 1,000, right? Because this is 1,000 times this. And so if I divide by 1,000, I'll work with a more simple formula. All right, so let's see what this gives us. This is 100 equals 1 plus 0.9 to the T. All right, now, can we make this both into the same basis? 0 on this number, 1.09? Definitely not. So we're gonna have to use the log. So get the log. Okay, so get the log of 100, get the log of the right, solve for T. So property 7 says if there's a power, you could put it in the front, right? So we're gonna put the power of T in the front, and the rest is a piece of cake, because obviously 10 times this number, how do you get T alone? How do you isolate T? The opposite of multiplying is dividing, so just divide by log of this number, which is 1.09. That means they canceled. Whatever you do to one side, you do to the other, so this is going to be log 1.09. So T, the years it would take for this to happen, is log of 100 divided by log of 1.09. So let me use our awesome calculator to make sure that we get it. So obviously the top is going to be 2, right? Because this is base 10. 10 to what power is 102? But in case you're skeptical, use your calculator, see what you get. Okay, so that's 2 on top, and then 1.09, get the log of that on the bottom. This one makes me put log in first. Yours might be put the number and then log. So again, you have to practice. You don't get a good grade without putting in the work and the time, right? But it's worth it. So 0.037. So 2 divided by 0.037. Okay. 2 divided by 0.037 is approximately 54. It would take about 54 years for this person to make $100,000 if they started off with 1,000 and with a rate of 9%. Okay, so have a good time. Make sure you're prepared for your exam number 4 on Tuesday and your optional final on Thursday. All right.